Welcome to Lesson 2, Analyze Statistical Data for Car Prices. Our objectives are to use measures of central tendency, like mean and median, and outliers, to analyze car prices. I've included a graph here. This is a scatter plot comparing different vehicles. This is another way to analyze data to help us make a decision. In the past, you have created scatter plots and drawn lines of best fit to help determine whether there was a correlation. In this case, we are drawing a scatter plot and we're using the market price, which is graphed, similar to a line of best fit, to determine where the vehicle that we found fits in. In this case, this green dot, which represents our vehicle that we would like to purchase, you can see that it easily has lowest miles and lowest price compared to most of the vehicles that are similar in nature. So by looking at this graph, I can tell right away that this is a good deal and maybe I should buy the vehicle. This is hopefully what our measures of central tendency will help us to do, is to analyze car prices to see what is a good deal, or for example, if we were selling a car, what should we sell our car for? Let's look at our first measure of central tendency, and that would be the mean or the average. To calculate the mean, this X bar represents mean, and this is equal to, and this big E is a sigma, so this means sum. So it's equal to the sum of all the data values, X being each of the data values, divided by N, which is the number of data values. That's the average, in case you've forgotten. So if we look at this, many graphs show averages. This is average car prices between January of 2010 and March of 2012. And just by looking at this graph of all the different averages, we can get an idea of the trend of car prices. It would be very difficult if we plot every single car in January of 2010 all the way through March. We would have umpteen jillion dots and it would be difficult to read. So a lot of times we'll look at average to help us make our decisions. You can determine a reasonable price for a particular car by examining the prices of those and similar cars listed in classified ads, and the mean or average will help you analyze those prices. That's a little bit what we did up here in this first example, is we took a bunch of different car prices and we compared them. Let's look at another statistical measure, and that's the median. Sometimes the median is a better indicator of what's typical when there are outliers skewing the mean. And we'll talk about outliers in a minute. But the median is just the middle number. If we place all the data in order from smallest to greatest, we just find the middle number, and that's the median. So it doesn't rely on the value of the numbers, just the placement of the numbers. In this example, we have an exact middle number of 6. In this example here, we don't. We have 3 on this side, and we have 3 on this side, so we have 2 middle numbers. If that happens, we just take the average of those two. 7 plus 8 is 15, divided by 2 numbers, is 7.5. Here's another example where we have 2 numbers that make up the middle. So, same thing, we would add these 2 together and divide by 2, and we get 45.5. So just know that sometimes your median will not represent an actual number that you have. Instead, it represents the placement of the middle of the numbers when you order them from smallest to greatest. Okay, let's look at what an outlier is. An outlier is just a piece of data that is extremely different from the rest of the data. An outlier will cause the mean to skew left or right. In other words, it'll adjust the mean. It'll change the mean and make it bigger or smaller. And it may or may not be an accurate representation of your mean. For example, in our quiz scores here, you can see that most of the people got 7, and probably the average would be somewhere between 7 and 8. But then we have this one person here who scored a 3. That might cause our mean or our average to move down to a 5 or a 6, but that wouldn't necessarily represent how everybody really did in the class. Maybe this person was absent or not paying attention. So in some cases, we can throw out the outlier to analyze our data better. Like this example down here, we have a perfect cubic function, it looks like, except for now we have this dot here that says your theory is wrong. But we're going to erase this dot because for the most part, this is an outlier. There's no other dots like it, and it looks like, in fact, we do have a cubic function. Let's try a couple of examples. In our first example, Jason wants to sell his Ford SUV, so he compiles these prices from the internet. And just in case you're looking, the Kelley Blue Book at this address and Edmunds at this address are two very good resources you can use to help you find the value of a used car. And it will show you the retail value as well as the wholesale value. So it's a good place to go if you're buying or selling your old vehicle. So in this case, he has compiled some different prices from the internet for cars that are similar to his. And remember that the reason we have such different prices for used vehicles is because there's different mileage. Also, some vehicles are better maintained than others, or some vehicles may have been in an accident. So we can have a lot of variability. But these are the prices that he has compiled. We want to know what a reasonable price would be for Jason to consider for his SUV. What would he sell it for? What we're going to do first then is go ahead and calculate the average or the mean and then determine if that would indicate a reasonable price for him to consider for his SUV. Remember that the formula to calculate average, and remember that x bar is our average, is equal to the sum of all the data values divided by how many we have. And we have 1, 2, 3, 4, 5. So I've summed up all my data values in order to get 52,500. And then I'll divide that by 5 in order to get my mean or my average. And I get 10,500. That is the average car price based on what he found. Now let's look at the numbers. 11,000, pretty close to this. 9,900, again, pretty close. 12, 10, and 9. These are all very close together. I don't see any outliers. I don't see any reason why this 10,500 wouldn't be a good representation. So this would be a reasonable price for Jason to consider selling his SUV for. All right, let's look at one more example. In this example, Doria is looking for a classic 1967 Firebird, and she finds these following prices on the internet. She computes the mean, so she has now calculated the mean, at $28,171.43. This number doesn't seem to be a good representation for the data. So how can she find a better representation? Now let's look at the data. Why isn't this a good representation? Well, if you're looking at the data, 18,000 is considerably lower than that. 77,000 is quite bigger. 22 is considerably lower, as is 21 and 19 and 17 and 22. So if you'll notice, most of the data is around this number, 18, 21. We've got all this data in this range. But for some reason, our mean is very, very high. Why is that? Well, hopefully you've recognized that the 77,000 is a very unique number. It doesn't look like any of the other numbers. It's considered an outlier. Well, what does the outlier do to our mean? In this case, the outlier is pulling our mean up. It's making it greater than what it should be. So in this case, we say that it is skewing the mean positively. So this mean would not be a good number to represent what I should pay for a Firebird. So instead, I could calculate the median in order to figure out a better number. I could also throw out the 77,000 and recalculate the mean if I wanted to do that. But let's go ahead and calculate the median and see if that looks better. First thing, I need to list my car prices in order from smallest to greatest. So I have done that. Now I need to figure out where my middle number is. Well, I have 1, 2, 3, 4, 5, 6, 7 pieces of data. So my middle number should be at data number 4. 1, 2, 3, 4 would put 21,200 as the middle. And we'll verify from the other side, 1, 2, 3, 4. So in this case, I have 3 data values on either side. 21,200, that is our median. Now if I look at the different car prices, 17, 18, 19, I've got a 22 and another 22, as well as the 21. I would say that the 21,200 is a better representation of our data than the 28,171. So always consider the median when we have an outlier that can affect and impact our median. This concludes our lesson today on statistical measures for car prices. So hopefully right now you are able to use the mean and the median, consider outliers to help you to analyze car prices.